workbench tonight, and it is night, as you can see. It's about 8:45 off my oscilloscope clock. There's the final resting place for it, right up over the door. On the workbench tonight, we got a beauty, a vintage Sony CD player, single disc CD player. This is a CDP-40, 1984 vintage. Let's see if it works. I have not tried this unit. This unit has been sitting forever, so there's a good chance it's going to need belts at a minimum. I press the eject button, and oh, there's a disc in this thing. Well, what is in here? It's interesting because it's okay. It's not ejecting the disc, so the belt is probably shot. But let's just see what's in here. There's a disc loaded. It's just reading a disc. Interesting. It works. I wonder what this is. Sounds kind of cool anyway, whatever it is. Let's pop the top off this thing and see what's wrong with it. So the CDP-40, it was one of Sony's earlier CD players. It's got some of this wonderful circuit glue this has been peeled up in the past to prevent problems. So that was already peeled up because the circuit glue, this yellow circuit glue kind of turns kind of brown and becomes conductive. So that was a problem that was well known on these and documented, and I did that years and years ago. So it's interesting that this thing is over 30 years old and it still works. Okay, let's see why it won't eject. Probably a belt. Yeah, I can hear the loading motor spinning, so I bet you the loading belt is broken and it's going to need a new one. So we got to take this mechanism apart, I think, to maybe not. There, just flip that lever, and that will allow the disc to pop out. That was how you open these ones up. There's going to be a belt that is slipping or broken. It's right here. Yeah, it's turned to mush, this belt. So let's just see if I can replace it. The belt is right there. There's the pulley. And this little belt has disintegrated. Well, it hasn't disintegrated, it's just turned to mush. See what I mean? Whoops. You notice what I mean about that fan making enough noise to wake the dead. I got to do something about that. That's noisy. But the belt is actually, well, not much left of this one. This belt is seeing better days. Let me see if I can find another replacement that'll work on this thing. Now this CD player, this was made back in the days of analog servos, before they had developed the digital servos of the modern CD player. So these were ones that you actually had to set them up on a scope. You had to look for the eye pattern, and you had to adjust the focus and the tracking servos and stuff to maximize the RF envelope. So maybe I'll show you guys that, and we'll look at the laser and so forth on this unit. So we just pull the little tabs back like this so we can release the disc tray, so we can access the pulley without damaging anything. Loop a new belt over here like that. So if we remove the disc clamp, you can see the laser assembly on this. These laser assemblies were very well built compared to the more recent generation. It's all an aluminum block, on here, and a lot of them use glass lenses. One of the common problems that happens is the laser rails need to be re-lubricated after a period of time. So while we've got this apart, we might as well just put a little bit of yellow grease on the rails themselves. So we're just putting a little bit of grease on those rails here and here. So the way to align a unit like this, once you've got it all apart, is make sure your cassette, or make sure your disc is in the disc loaded position, and then you can insert the disc, or insert the disc tray in the fully loaded position like this. And snap it down in place. Okay, now that we've found a rubber band, I mean a belt, no, in this case I mean a rubber band that's the right size, we'll put the clamp back in. Now this rides in a groove inside the, I'll show you guys here, inside here that this has to ride into, and then you snap it back in like that, and the other side snaps down like that. And now when I open it, the tray opens. When I close it, the tray closes and the clamp lowers. Now we can put the front back on. Replace the screws. Okay, power on. This tray's open, play. It loads up, just spins, and we have music. Now, we want to check the servo alignment. So the test point to test your RF is this one here, test point 4, RF. And what you'll see on the scope is you'll see the eye pattern. So this is what they call the RF eye pattern, and what you're looking for is you're looking for a nice symmetry here between the waveforms. And this one's not perfect because this is a 30-year-old machine. We are seeing a bit of jitter here, but what you would do is optimize with the focus and tracking controls. You would optimize that waveform for the clearest eye pattern here. This is an eye pattern here. You want these to be clear, and that was done by tweaking the controls. If I adjusted the tracking and focus control, you'd see the levels here change. The relationship of these levels would change, and then the unit would start to skip and sound distorted and sound awful. So anyway, that's what you adjust on these old machines. On the newer machines, that was all done digitally, but these old ones had to be set up manually. We'll look at some of the other circuitry on this unit here. I'll explain the different paths that the signal takes. So IC109 is your digital to analog converter. It's actually a combination of IC109 and I think it's this one here, IC402. This is where your digital bit stream goes in and audio comes up. So if I put my scope on one of the input pins, for example, what we're seeing here is we're seeing the digital bit stream coming off the laser going in. If I stop it playing, put pause for example, our bit stream goes away. And if we go over and scope the output pin, that one? No, it's that one there. There's one of the output channels there. And there's our audio signal coming out, as you can see. This was a very simple unit. It used an analog low pass filter That analog low pass filter is back in this section over here. And basically what the analog filter did was it takes the digital noise, because there's no oversampling on this. It's sampling at 44.1 kilohertz. This is long before the oversample machines hit the market. So actually this one might be a 2 times oversample. I'm not sure. It's pretty old. It may be a 2 times oversample, but it definitely has an analog low pass filter. You can see it right here. LPF, low pass filter 401, and LPF, low pass filter 301. And if I scope the input, you'll see audio going in. And then if you scope the output, you'll see the filtered audio coming out. There's the input signal going in. And if I look at the output signal coming out is, where is it? There it is coming out. And we amplify that a bit. There's the output. And there's the input. Looks the same. One's got the switching noise from the D to A converter on it, and the other one filters out the frequencies above 20 kilohertz is what it does. And that's basically, that's it. Pretty simple unit. It's a classic old machine. As you can see, new belt on there, and the unit is working perfect. It's got a nice fluorescent display on here. Shows me the time, how much. There's 3 tracks on here, 73 minutes. Basic unit. Press play, plays. You've got skip forward, skip backwards, AMS to the next track. It's not the speediest unit in the world as far as accessing tracks, because it has to search them out. Anyway, it for a 30-year-old machine, I think it's doing pretty good. Thanks for watching. We'll catch you in the next video. Here we go. That's the time now. Gonna call it a night on this one. Thanks for watching.